Now we are going on to one of the well-known laws in theory, that is De Morgan's laws, and the law has two parts. Now, when we consider two sets A and B, A union B complement is equal to A complement intersection B complement, and A intersection B complement is equal to A complement union B complement. And of course, we know what a complement is. That is the elements which doesn't come under the basic operation, in the sense that A union B complement refers to those elements which aren't present in A union B. So that's the meaning of it. And now let's go to the proof of the first part. That is A union B complement is equal to A complement intersection B complement. And as in the case of all such operations, or all such proofs, we had to choose an arbitrary element, and X is chosen as an element of A union B intersection. A union B, A union B complement. And now A union B complement, what does it mean? It means that the elements chosen are not those of the union of A and B, which simply means that X is not an element of A union B. And when we are saying X is not an element of A union B, it simply means that it cannot be an element of A and it cannot be an element of B, which in the reverse means that X is an element of A complement and X is an element of B complement, which simply means that if X belongs to both A complement and B complement, it should be an element of A complement intersection B complement. Therefore, we can see that A union B complement is a subset of A complement intersection B complement. Now, for a conclusive proof, we had to go to the second part and choosing another arbitrary element, that's Y. And Y is an element of A complement intersection B complement. Now you can see that we are step by step giving the proof of both sides of the particular equation, so that we reach a total conclusive proof. So looking at A complement intersection B complement, what does it mean? It means that the Y, which is an element of A complement intersection B complement, indicates that Y is both an element of A complement and B complement, because the intersection means we are looking at the common elements. So Y is an element of A complement and Y is an element of B complement. Not the point that we are it's written and, because we are dealing with an intersection. So if it's an element of A complement, naturally it cannot be an element of the set A, which means that Y is not an element of A and Y is not an element of B. And of course that means Y cannot be an element of A union B, which simply means that the reverse is true, that is Y is an element of A union B complement, which leads us to the second conclusion, that's A complement intersection B complement is a subset of A union B complement. And the key point here is that we know that when we have looked at the previous particular video, that if A is a subset of B and if B is also a subset of A, then it simply means that, so if A is a subset of B and B is a subset of A, then naturally A should be equal to B. So that's the same thing which we are coming here. So it simply means that if A union B complement is a subset of A complement intersection B complement, and A complement intersection B complement is a subset of A union B complement, that means it's both the reverse. So the reverse is also true. It's that simply means that A union B complement is equal to A complement intersection B complement, and that's a first law in De Morgan's laws. Going on to the second law. Uh, Again, we are taking the same. We are utilizing the same technique. Taking an arbitrary element, if S is an element of A intersection B complement, it simply means that X uh, X X X cannot be an element of. So this is just a small mistake over here. It simply means that A cannot be an so 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 if X is an element of A intersection B complement, it simply means that X cannot be an element of A in the intersection B. It simply means that it's which of course means that X is not an element of A, or X is not an element of B. Now, if X is not an element of A, it simply means that it should be an element of A complement, and that's the step. That is, X is an element of A complement, or X is an element of B complement, and that means X is an element of A complement union B complement, and therefore A intersection B complement is a subset of A complement union B complement. And let us look at the other part of the equation, and that's we are choosing another arbitrary element X, sorry, Y, and we are choosing Y because not to confuse with the first part, with the proof of the first part. So if Y is an element of A complement union B complement, it simply means that Y should be an element of A complement, or Y uh, Y is also an element of B complement. An element of A complement means that Y would not be there in A. That is, so Y is not an element of A, or Y is not an element of B. Naturally, in that case, Y is not an element of A intersection B. And if it's not in A intersection B, it should be in A intersection B complement. And that's the next one. That's Y is an element of A intersection B complement. That leads us to the second conclusion, that is A complement union B complement is a subset of A intersection B complement. And as I already told in the first part, in the proof of the first part, if A is a subset of B and B is also a subset of A, then we are dealing with the equal sets. That simply means that A intersection B complement X equal to A complement union B complement, and that gives us the proof of the second part of De Morgan's law. So the points we have to look at here is that you prove you uh, deal with each part of the equation and come up with a subset part. I mean, in cases like this, that's how you derive the proof, and we'll be looking at a number of problems of the same kind, and we'll try to come out with a general method to for bringing out proofs of such cases. So, and you have to, so you end up with proving a proof, giving proof something like A is a subset of B and B is a subset of A, so something like that, to conclusively prove, give the proof of a particular equation. So thank you.